Good evening, ladies and gentlemen. At this time, we are going to go through the totality of the Unit 2 test. So, today in class, you should have received a copy of your test and your response sheet. So, let's start with the first question. If the x in the rational parent function is replaced with x plus 8, how is the graph changed? The first thing you had to recognize is that the rational parent function is the equation y is equal to 1 over x. And now we are going to compare that to y is equal to 1 over x plus 8. Now you will notice that the plus 8 is inside the denominator. And what do we remember about insiders? They always lie. So you would think that you would shift 8 units to the right. But since insiders lie, you will shift 8 units to the left. Now, if you don't believe me, we can look at our handy-dandy graphing calculator. So, we're going to go to our y equals, and we are going to do y is equal to 1 divided by x. That's our parent function. And then we're going to look at 1 divided by x plus 8. And then we are going to graph. And there's our original function. And then our transform, as you can see, has moved 8 units to the left. And that's it. Now, let's take a look at the next one. We are going to compare the rational function of the positive absolute value of x Okay, so let's actually take a look at the functions and see how it looks. I'm going to pull the plug on this because we don't need to have that cable coming off the top. Okay. So once again, we're going to turn our calculator on. We're going to take a look and see what that looks like. So our first function is, of course, 1 over x. And our second function is going to be 1 divided by the absolute value of x. Now, the way you're going to get the absolute value is you're going to hit the math key. You're going to scroll over to num, and you are going to select absolute value. ABS does not stand for anti-lock brakes this case. And once we have that, we're going to graph them, and we're going to see what it looks like. So there's our first rational function, and there is our second. So you will notice, and let's go back to our y equals, if I turn off the first graph, you notice we will have negative x values over here. So we know that answer choice 1 is clearly false. We also see that there is an asymptote. Can't see that too well because of the shadow. Here we go. You see that there is an asymptote. So we know that the second choice is obviously false. So now comes the rub of, is it symmetrical to the x-axis or the y-axis? Symmetric to the x-axis would have us graphing stuff down here. As you can see, we are not graphing anything below the x-axis, and so it is not symmetric. And so even if we are not constructing the correct response, we can eliminate the wrong answers. Okay, now let's take a look at number 3. Now, number 3 is a little bit abstract because they did not give you a number. They asked you to see what happens when k is changed. Now, if I don't know my formulas forward, backwards, up, and down, I'm going to just pick 2 numbers and just go with it. So I'm going to say, okay, I have x minus 5 quantity squared plus 2. Now I just pulled these numbers out of nowhere. But if I'm going to see what happened when the k's change, I'm going to do the exact same numbers, except I'm going to change that constant at the end. So I'm going to say, okay, x minus 5, quantity squared. Let's say plus minus 3. Okay? So let's hit graph. And there is our first quadratic. And there is our second quadratic. You will notice, now the most important feature of any quadratic is the vertex. So basically my quadratic just moved down. Okay? So we know it did not shift horizontally. We know it didn't get narrower, and we know we didn't get wider. And so again, our process gets us that this was a vertical shift. Now, let's take a look at number 4. So they gave you a graph of y is equal to 4x squared minus 8x plus 2. And we are going to shift this 3 units lower. So we are going to subtract 3, right? What's 2 minus 3? 2 minus 3 is negative 1. I have no other like terms, so I'm left with 8x, 4x squared. And as you can see, that leaves us with answer choice J. Okay? Now, number 5 requires us to remember our vertex form. And that is to remember that y is equal to x minus some h, or some number a times x minus h, quantity squared, plus our constant k. Where h is horizontal shift and k is vertical. So if I'm shifting down, that tells me that k is equal to negative 3. And if I'm shifting left 5 units, that tells me that h is negative 5. Now, the thing we have to remember is that insiders lie. So that leaves us with y is equal to x. Now if I have a minus 5, I have plus 5 squared. And if I am adding a negative 3, I am subtracting 3. And so that leaves us with our final solution, which is A. Okay. For number 6, write an equation for a parabola that has the same width, opens upward, shifted 8 units up, and 4 to the left. So that tells us something. If it's shifting upwards, that means A just became positive. That means K, 8 units up, so that's positive 8. And that tells us that H is negative 4 because it's 4 units to the left. So now, I know right off the bat that H is wrong because it's negative. I remember that insiders lie, so I know that my equation is going to be that y is equal to 6 times x plus 4 quantity squared plus 8. So that means I can eliminate j because 8 is negative here, and I can eliminate f because insiders lie. And so there's our final solution. Okay, so let's take a look at the next one. Just like before, we have a vertex form with our square root. That's going to be y is equal to a times the square root of x minus h plus a constant k. Okay? H is your horizontal shift, k is your vertical shift. In this case, it's asking what h is doing, so we say a is the horizontal shift. That you simply had to recall as a matter of memory based on your notes and based on using the formulas. Okay? Okay. So this tells us, once again, we use the principle of insider's lie. Now with a rational function, it is that y is equal to 1 over x minus h plus a constant k. And so our k is that y is equal to negative 4. So our k is negative 4, and our h is 2. Of course, insiders lie, and so we can eliminate h and f because here k is positive. And insiders lie, so I have 2, but I remember insiders lie, so the correct response is j, because this is x minus 2. Okay? Now, number 9 is what is a logic. Okay? There are 4 choices, or there are 4 logical statements. What you need to do is you need to evaluate each of them as true. So the first statement of the 2 curves, are they inverses? This is true. This is true because these 2 lines, or these 2 curves, are reflected across the line y equals x. Now, are they reciprocals? That has not been proven. Is one a translation of the other? Remember, translation is when you slide. Now, can I slide this shape over and have it change directions? No, translation is slide. So we know that is false. Is this a reflection? We see very clearly this is a reflection, so we know that is true. And I am willing to bet that they are not reciprocals, but even if they're not, let's just see what choices we have. Both 1 and 2 are true. Well, we know 1 is true, and we know 4 is true. But since A did not mention 4, we know 4 is wrong, or we know A is wrong. 1, 2, and 3 are all true. Well, we know that 3 is clearly false. So we can eliminate B. It says 2 and 4 are both true. We know that 4 is true, but we're not sure about 2, and we also know that 1 is true. And since C does not mention 1 at all, we know that's false. And so now, even though we didn't have a complete picture, with just 2 of the choices validated, you can arrive at the correct solution. Okay, let's turn the page. What is the inverse of the function? Finding an inverse is a 2-step process. Step 1, switch x and y. Step 2, solve for the new y. So, here we have 1/3 of x squared minus 2. We are going to turn that into x is equal to 1/3 of y squared minus 2. Our next step is going to be to solve for y. We are going to add 2 to both sides. That cancels. So now I have x plus 2 is equal to 1/3 of y squared. Now I'm going to cancel the 1/3. The opposite of taking a third is to multiply by 3. So now I have that y squared is equal to 3 times x plus 2. I'm going to use my reflexive property to make this a little neater. Y squared is equal to 3 times x plus 2. The last thing I'm going to do is I am going to cancel the square. What cancels the square? The square root. Now, when you are taking the square root of y squared, you have to remember that you are going to have two solutions. You are going to have a positive solution, and you're going to have a negative solution. So that leaves us with y is equal to plus or minus the square root of 3 times x plus 2. Now, that is not listed in your choices, but you can distribute the 3. And so you clean that up just a little bit more and you say y is equal to plus or minus the square root of 3x plus 6. And that is your final solution. Okay. Graph of a function and its inverse are reflections with respect to what line? That is the line y is equal to x. You had to know that as a fact. Next one, write the inverse of this equation. Once again, you are going to switch the x and y and solve for y. So you turn this into x is equal to y minus 6 over 4. My first step is to cancel the 4 by multiplication. So now I have 4x is equal to y minus 6. Cancel the subtraction by 6 by addition. And you are left with 4x plus 6 is equal to y. And you clean it up using the reflective property. Y is equal to 4x plus 6. That is our final solution. And you will find that that is J.
That was easy.
All right. Let's take a look at 13. Which of the following points would be on the inverse of the graph? Okay. This one was a little bit of a doozy. The thing you had to recognize is that with a graph such as this, you would switch the x and the y. Now, they gave you some definite points. Let's actually plot some of these definite points. Here you had 1, 3. Now, the inverse of that, now let's go on ahead and plot all of these points. So we have a table. So you had 1, 3. You had 2, 2. And you had 2, 4. Okay. You next had 1, 2, 3, 4, 5, 1. And you had 5, 1, 2, 3, 4, 5, 5, 5. Okay. So that's your original. Okay, now let's take a look at the inverse. The inverse would have us switching the x and the y. So we have 3, 1, 2, 2, 4, 2, 1, 5, 5, 5. Now, if I look at the points here and look at the points here, I find that the only one that works is C. That was not easy. That was exquisitely painful. That one was a bear. Let's go on. Which graph is the inverse of 2x minus 3? Now, you have two choices. You could graph it and see which one was a reflection, or you could find the inverse and then identify it. I'm going to try graphing it. Nah, I'm just going to switch it. Okay, so x is equal to 2y minus 3. Add 3 to both sides. So now I've got x plus 3 is equal to 2y. So now I've got divide both sides by 2. So now I have that x over 2 plus 3 over 2 is equal to y, or y is equal to 1/2 of x plus 3 over 2. Now, a couple of things I can do to make my life easier. I observe that the inverse has a slope that is positive. That allows me to eliminate g and h immediately. G and h both have negative slopes. I look at my y-intercept, I see that my y-intercept is positive. That allows me to eliminate j immediately from consideration. So the only line, even without going into meticulous detail about the fact that this has a slope of 1.5, and that this actually does have a slope of 1 over 2. Because the intercept is positive and the slope is positive, I can eliminate all the other answer choices without getting into too much detail. Okay. Let's take a look at 15. Jackson is flying at a constant rate of 500 mph from New York to Austin. If the distance traveled is in miles as a function of time in hours, what is an appropriate range for the problem? Okay. There is no way to travel for infinity. That is not an appropriate range. So immediately we can eliminate from consideration A and B. Actually, I stand corrected. There is no way I can go backwards in time. Time can go on ad nauseum. Now, if I'm traveling 500 mph, my distance is 1750. It takes me 3.5 hours to get there, but that's not what it asks. It says, what is an appropriate range for the distance as a function of time? Okay? Because it says the distance is a function of time. So obviously, distance could be infinite, but we're not going to do that. 1750 was the distance, right? Okay, so once you've traveled the 1750 miles, you're not going to keep traveling. And so that is our correct response. In other words, the distance traveled, when you're going on a trip, you will travel till you get to the end. That was the trick. The 0 to 500 was just to mess with you because 500 was the miles per hour, which is a rate which has nothing to do with the distance, or very little. Okay. For number 16, y plus 5 is equal to the base of x is moved in what way? Here is the thing you have to recognize. Do I like having y with its friends? No, I do not. So what you are going to do is you are going to say, okay, y plus 5 is equal to b of x. I am going to subtract 5 from both sides. And b to the x minus 5 is b to the x minus 5. Now typically when I have a constant out here all by itself, if I'm subtracting 5 from the y, which way am I going, up or down? I am going down. So the correct response is G. Okay, next one. Which of the following is an exponential growth function? Okay, process of elimination time. B is a rational function, not what we want. D is not growing very fast, that's a log. C is a square root curve. The only one that's an exponential growth is an A. That's a high. Do you remember your notes, and do you remember what an exponential growth curve looks like? You either know it or you don't. Okay, which of the following functions has a domain that requires x to be greater than or equal to negative 5? When we're talking about domains and square roots, that means we cannot take a square root of the negative number because the square root of a negative number is imaginary. Okay, so right off the bat, since I'm worried about x cannot be greater than negative 5, immediately I can eliminate from consideration f and j because there isn't even a 5 inside the square root. Now, if x is greater than negative 5, that means it can't be less than. So here's what we have to think of. Okay, we have to look at both of these two and figure out which one fits. Now, I also remember that insiders lie. So what I am saying is that x plus 5 has to be greater than or equal to 0, and then I'm going to solve for x. I'm going with h for a moment. I'm not sure. I'm going to confirm that as we go through it. So I'm going to subtract 5 from both sides, and so now I have x is greater than or equal to negative 5, which is exactly the precondition I was looking for. This one has the domain that x has to be greater than or equal to positive 5, because once again, insiders lie. 19, how does the graph of y is equal to the square root of x minus 6 minus 2 differ from the parent of the graph? So, insiders lie. So I'm going 6 to the right. and here's my vertical shift of -2, so I'm going to say that's 2 down. And then I look. 6 units to the left? Nope. 6 units to the right? Maybe 2 units down. Looks like a good shot. 6 units down? Nope. 6 units up? No. So, even if I'm not entirely sure, I still want to go with each of my answer choices just to double check to make sure I didn't do anything foolish. Number 20. Is the given graph a function? The answer is false. It fails vertical line test repeatedly. So,
That was easy.
okay. Last one. The domain of 3 to the x plus 7 is all real numbers. Let's actually graph that and see. Now, you will notice that it goes all the way to the left and then it starts to go up. And we know it's an exponential, so it keeps going. So the domain is between -infinity and +infinity. X is in the middle. And so, yes, that is all real numbers. The statement is true. Okay. Just when you thought you were finished, not quite. Okay. Same question, same word problem we had before, except now we're looking for the domain. If the distance Jackson has traveled in miles is a function of time, that means we're talking about time. What is an appropriate domain? Now remember, we're talking about a problem situation where a person gets onto an aircraft, flies, and lands. After they've landed, they're not going to keep going. So when we're talking about an appropriate domain, we're talking about real world. So, one does not travel on an aircraft for infinity time. So F is absolute crap. Pardon my French. Absolute distractor. Once again, we can also eliminate H and J from consideration because we will not travel for infinity. The only one that works is between 0 and 3.5. 23. John's dropping an object. This is the path of the object. If the new function is a building that is 300 feet tall. Here we notice that we have 195, and that is the height of the building. So now we need an equation that has 300 and the height of the building. Now, A is the only one that works because this does not have 300 per se. It does not have 300. This is extra. Where did we talk about 195? We talked about it in terms of feet, not in terms of velocity. So this is a distractor. And this implies that we started 300 feet underground because 300 is negative in answer choice D. So once again, process of elimination, and you will arrive at that one. Okay, next one. Which of the following is an inverse of the given graph? Now remember, inverses are reflections. So in my mind's eye, I'm going to draw a little sketch, and I'm going to see, okay, which of these actually looks like the inverse of this? F does not look like that. G looks really close. H does not look like anything that we want, and neither does J. So the only one that even comes close is G. See? First half, second half. Okay, last one. Okay, given the table below, which one represents the inverse functions? So again, we are looking to swap the x and the y values. So, we can go on ahead and make our own right here off to the side. So, our new x is going to be our old y. So, we're going to have 0, 3, 6, 9, 0, 1.5, 3, and 4.5. So, we already know right off the bat that A is wrong. We already know right off the bat that B is wrong. C and D both look good. Let's double check. 0, 3, 6, 9. Okay. 0, 1.5, 3, 4.5. Think we have a winner. Let's double check the last one just to make sure that Mr. Saberian wasn't being too evil. 0, 3, 6, 9. Oh! Oh! Negative values. Negative values. Oh, man. That's Saberian. He's a tricky man. He almost got us. Almost got us. All right. Correct response was C. Okay, so that concludes our corrections. If you have any questions, feel free to ask me in class. And again, you can always pause and rewatch the video. Instant replay. Works for the NFL, works for me. Okay. Good luck. If we did bad on the first test, we need to come in for corrections ASAP. That grading period is closing fast.